Right now, as you are watching this, the Pacific Ocean is running a fever that the official classification system does not have a category for. On the 13th of August, 2026, NOAA's Climate Prediction Center kept the country under an El Niño Advisory and stated that the event is strengthening, with a greater than 90% chance of a very strong El Niño during the fall and winter of 2026 into 2027. In the July discussion, the weekly Niño 3.4 index sat at plus 1.2 degrees Celsius, with the Eastern Niño 1+2 region already at plus 2.7. The International Research Institute for Climate and Society described the October to December outlook as off the charts, noting that its own intensity classification stops at plus 2 degrees, while 15 separate models were forecasting Niño 3.4 anomalies reaching or exceeding plus 3. The Climate Prediction Center puts the odds of El Niño persisting into early spring 2027 at 97%. That is not a storm forecast. That is a reorganization of the atmosphere over North America for the next 6 months. So today we are going to break down exactly what is happening in the Pacific, what it has historically done to specific regions of the United States, which hazard actually kills people in an El Niño winter, and what you can do about it starting this week. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now and tell me this. What was the worst weather event you have personally lived through? Not read about, lived through. Tell me the state, the year, and what it actually cost you. A roof, a car, a week without power, a night in a hallway. Thousands of you watching this are in Florida, Texas, Louisiana, California, and the Carolinas, and your experiences matter more here than any model output. If you want to be the first to know every time this pattern shifts, subscribe right now. It is completely free. A thumbs up helps enormously. Let us go for 5,000 likes so the algorithm shows this to people who need to see it before the winter, not after. Let us start with what El Niño actually is, because the term gets used as a synonym for bad weather, and it is nothing of the sort. Across the tropical Pacific, the trade winds normally blow from east to west, pushing warm surface water toward Indonesia and allowing cold water to well up along the coast of South America. El Niño is what happens when those trade winds weaken or reverse. Warm water sloshes back east. Sea surface temperatures across the central and eastern equatorial Pacific rise above normal, and because the atmosphere sits on top of the ocean, the thunderstorm activity that normally clusters over the western Pacific migrates thousands of kilometers east with it. That migration is the whole story. Thunderstorms release enormous amounts of heat into the upper atmosphere. Move the heat source, and you move the winds that respond to it. The subtropical jet stream, a high-altitude river of air that steers storm systems, strengthens and shifts south across the southern United States. The polar jet, which normally delivers cold outbreaks to the northern tier, tends to retreat. That is why an ocean anomaly measured in tenths of a degree, 5,000 miles away, decides whether it rains in Los Angeles in February. Now let me explain the numbers being reported, because they are not being reported carefully anywhere else. The primary index is Niño 3.4. The sea surface temperature anomaly averaged over a defined box in the central equatorial Pacific. Under the standard classification, a 3-month average of plus 1.5 degrees or higher is considered a strong event. Plus 2 is very strong. There's no formal category above that, because until recently, nothing needed one. The Climate Prediction Center's July 2026 discussion reported Niño 3.4 at plus 1.2, the far eastern Niño 1+2 region at plus 2.7, and the western Niño 4 region at plus 0.5. And that distribution matters enormously, and here is why. When the warming is concentrated in the eastern Pacific rather than the central Pacific, forecasters call it an Eastern Pacific event. The two strongest El Niños in the modern record, 1982 to 1983 and 1997 to 1998, were both of that flavor. The 2026 event is following the same geography. The discussion also noted a recent downwelling Kelvin wave that deepened the thermocline and raised temperatures in the eastern Pacific. In plain language, a slow pulse of warm water traveling east beneath the surface had arrived and pushed the boundary between warm and cold water deeper, cutting off the cold upwelling that would normally moderate the surface. That is the engine that turns a warm anomaly into a strong one. And the Climate Prediction Center's official strength probabilities went further than the headline. Its own product gives the October to December season a substantial chance of a 3-month relative index value at or above plus 2.5 degrees, a value that would exceed every El Niño in the record going back to 1950. Now let us talk about what that actually does to the United States, region by region, based on what past strong events have delivered, rather than on speculation. The southern tier gets the storm track. In strong El Niño winters, California, the Southwest, Texas, the Gulf Coast, and the Southeast all tend to run wetter than normal. because the strengthened subtropical jet drags one Pacific system after another across the southern half of the country. In California, that arrives as atmospheric rivers, narrow corridors of concentrated water vapor, sometimes only a few hundred miles wide, that can transport more water than the Mississippi and deliver a season's rainfall in a matter of days. Where those storms cross ground that burned this summer, the consequence is not flooding in the ordinary sense. A burn scar has lost the vegetation and the root structure that normally slow water down, and the soil itself is often chemically water repellent after intense fire. Rain that would have soaked in instead sheets off, gathers ash and rock, and arrives downhill as a debris flow, a moving slurry of mud and boulders rather than water. More than 3.3 million acres have already burned across the country this year, well above average, much of it in the west. Every one of those acres is now a catchment waiting for a Pacific storm. The northern tier gets the opposite. The Pacific Northwest, the northern Rockies, the upper Midwest, and the Great Lakes tend to run warmer and drier, with reduced mountain snowpack. That is not a comfort, and this is the single most misunderstood consequence of an El Niño winter. Snowpack is not weather, it is infrastructure. Across the western United States, mountain snow functions as the largest reservoir in the system. It accumulates through winter, then releases slowly through spring and summer, feeding rivers, irrigation, and municipal supply exactly when demand peaks. A warm winter does not simply mean less snow. It means more of the precipitation that does fall arrives as rain, runs off immediately, and is gone by April. A mild, pleasant December in Montana is a water rights dispute in July. The middle of the country generally sees a quieter, milder winter with fewer severe Arctic outbreaks because the polar jet is displaced north. That is genuinely good news for heating bills and for road crews. It is also the reason people in those states tend to stop paying attention, which brings us to the part of this pattern that has actually killed the most Americans. Let us do the comparison that decides how seriously to take this, because it already happened twice in the same place. By October 1997, the National Weather Service office in Melbourne, Florida, had publicly highlighted the potential for enhanced severe weather over the coming months because of El Niño. An El Niño summit was convened in Tallahassee on the 15th of December, 1997. Additional warnings were posted for East Central Florida. The forecasting worked exactly as designed. On the 22nd of February, 1998, jet stream winds of up to 160 miles per hour ran across the Gulf of Mexico and Florida. The Storm Prediction Center upgraded the region from a slight to a moderate risk that morning. A hazardous weather outlook that evening warned that another round of severe weather was expected. Tornado Watch number 58 was issued at 8:13 that night. Between 10:55 p.m. and 2:30 a.m., 3 cyclic supercell thunderstorms, the kind normally associated with the Great Plains, not Florida, produced 7 significant tornadoes across central Florida. 3 were rated F3. Damage tracks ran from 8 to 38 miles. More than 3,000 structures were damaged and more than 700 destroyed. 42 people were killed. More than 260 were injured. It remains the deadliest tornado event in Florida's history. The previous record was 17. Let me explain why El Niño specifically produces this, because it is not a coincidence and it is not folklore. Florida almost never gets Great Plains-style tornadoes because it almost never gets Great Plains-style wind shear. What Florida usually has in abundance is heat, humidity, and instability. Plenty of fuel, but nothing to organize it, so storms grow vertically, dump rain, and collapse. Wind shear is the missing ingredient, a change in wind speed and direction with height, which tilts a storm's updraft away from its downdraft and allows it to rotate and sustain itself instead of raining itself out. A strong El Niño supplies exactly that missing ingredient. The southward displaced subtropical jet runs directly over the Gulf and the peninsula at speeds that reached 160 miles per hour that night, while a low-level jet of over 50 miles per hour pushed warm, moist Gulf air northeast underneath it. Winds screaming one direction near the surface and a different direction 6 miles up is the textbook recipe for supercells, and Florida in a strong El Niño winter is one of the few times that recipe assembles over a subtropical peninsula full of manufactured housing. That is why the 1998 event was not a freak. It was the pattern doing what the pattern does. The National Weather Service's own service assessment and later research by Bartlett Hagemeyer and colleagues at the Melbourne office identified what actually went wrong, and it was not the forecast. The deaths occurred despite tornado watches and warnings issued with long lead times. The event happened overnight when people were asleep, and the fatalities were concentrated overwhelmingly in manufactured homes and recreational vehicles. Then it happened again. On the 2nd of February 2007, in the early morning hours, 21 people died in central Florida under almost identical circumstances. Another El Niño, another overnight outbreak, another cluster of manufactured housing. The Melbourne research team's summary of those two events is stark. 63 Floridians killed within a 30 nautical mile radius of Sanford in a matter of a few hours across 2 nights, which is more than everyone killed in Florida by direct hurricane winds since at least 1950. Read that back one more time. 2 El Niño winter nights killed more Floridians than every hurricane wind death in 3/4 of a century. So what was the actual failure point? In 1998, the only way for a sleeping person to receive a tornado warning was a tone-alerted NOAA weather radio. The information existed. The transmission path to a sleeping human being did not. That is the single thing that has genuinely changed since. Today, the alert can reach almost every phone in a warned polygon, but it only reaches you if wireless emergency alerts are enabled, if the phone is not silenced, and if it is not sitting face down in another room. The 1998 gap has not been closed by technology, it has been converted into a settings menu. So when you see this pattern building, the natural instinct is to ask whether this is unprecedented and whether something has fundamentally broken. Is this normal? The honest scientific answer is that El Niño itself is entirely normal, but the magnitude being forecast is not. The El Niño Southern Oscillation has been swinging back and forth every 2 to 7 years for as long as we have records, and proxy evidence extends it back millennia. It is one of the most thoroughly documented natural climate cycles on Earth. Roughly half of all winters are neither El Niño nor La Niña. The pattern is not a malfunction, it is the system breathing. What is unusual is the projected amplitude, when the official intensity classification stops at +2 degrees and 15 models are forecasting values at or above +3. The issue is not that the ocean has done something impossible, it is that the categories were built from a record that did not contain an event this large. It also matters that El Niño is a probability shift, not a schedule. A strong event loads the dice toward a wetter southern tier and a warmer northern tier. It does not guarantee any particular storm on any particular date, and there have been strong events that underdelivered rain to Southern California. Any forecaster telling you exactly what will fall on your town in January is selling something, and there is a genuine benefit in the near term. Strong El Niño events increase vertical wind shear across the tropical Atlantic, which tears developing hurricanes apart. In a season that peaks in September, that is not a small thing. What changed is not the ocean's behavior. What changed is how many people now live in the corridors that this particular pattern favors. The Gulf Coast, the Florida Peninsula, the California burn scars, and the floodplains of the American South. Let us be direct about the practical message here, because information without action is just anxiety. Florida in 1998 shows what happens when a correct forecast, a correct watch, and a correct warning all arrive and the population is asleep in structures that cannot survive an F3. California in a strong El Niño shows what happens when months of Pacific storms arrive on ground that burned in August. The Pacific Northwest shows what happens when a warm winter quietly removes next summer's water. Here is what you can control, and most of it takes one afternoon. Turn on wireless emergency alerts on every phone in your house, and do not silence them overnight. Buy a tone alert NOAA weather radio with battery backup, $30, and it is still the only device that will reliably wake you when the power and the cell network are gone. If you live in a manufactured home, identify tonight where your nearest sturdy shelter is and how long it takes to reach it, because a mobile home is not survivable in a strong tornado, and no amount of interior room advice changes that. Clear your gutters, storm drains, and roof valleys before the first Pacific system arrives. If you are in or below a burn scar, know your debris flow evacuation route now. Check your flood insurance. Most new policies carry a 30-day waiting period, which means a policy bought in January does nothing for a January storm. Photograph every room for your insurer. Keep 2 weeks of water, medication, and a torch. Trim the limbs over your roof. And if you are in the northern tier, treat a warm, dry winter as a summer water problem, not a mild weather gift. Final thought. The Pacific has been doing this for thousands of years. Trade winds slacken, warm water sloshes east, the atmosphere rearranges itself around the new heat source, and continents on the far side of the planet get a different winter than the one they expected. This will keep happening long after everyone watching is gone. We cannot stop El Niño. We cannot switch it off, steer it, or bargain with it. What we can do is act on 6 months of warning, which is more warning than any other natural hazard on this list will ever give you. Earthquakes give seconds, tornadoes give minutes, hurricanes give days. This one has been announcing itself since June. Florida showed what happens when a warning is broadcast perfectly and lands on a sleeping population in the wrong kind of building. The forecasting community has done its job, the advisory is public, the probabilities are published, and the mechanism is understood down to the depth of a Kelvin wave in the equatorial Pacific. The open question this winter is not what the ocean will do. It is whether anyone will move before the water and the wind arrive. We will keep tracking every update as it comes. Subscribe so you do not miss it. And leave that comment below. What is the worst weather you have personally lived through, and what did it cost you? Because these are not just atmospheric patterns. They are human experiences.